Hey everyone, today's lesson is on reflections. So far we have done congruent figures and we've done translation, so our next one is on reflections. These are all different types of transformations and this is chapter 2.3. So to start, we're just going to be reviewing a transformation. Again, this is the same as our last video. A transformation changes or manipulates one figure into another, and that new figure is called an image. Now we're going to move on to reflection. Reflection is a type of transformation where a figure is flipped over a line. This line is called the line of transformation, the line of reflection. So the line of reflection is the line where an image is reflected over. This causes a mirror image. When we're looking on a coordinate plane, each coordinate is going to be the same distance away from that line. So if you look at this picture, in the top right we have a mountain, and then we obviously have a reflection of that mountain on a lake. And if you look, the top of the mountain and the bottom of the mountain are about the same distance away from the line in the middle, and same with the trees. So everything is being reflected over this line in the water, and the different points that we can see are about the same distance away. And if you look, when I flip over the image, it kind of looks almost like the same picture. I just flipped it over so you can see. So pause the video here and write reflection and line of reflection down in your notes. And then we'll move on. So how do we identify a reflection? When we're identifying a reflection, again, we need to make sure that it's creating a mirror image. So on this mountain, the peak is on the top of this picture, but in the reflection, the peak is at the bottom. So we want to look for the same type of characteristics when we're identifying a reflection. So on this one, we have two examples. We have this one here. So is the blue figure a reflection of the red figure? If I was to take the red figure and flip it over the line, would it then create the blue figure? And yes, the red figure can be flipped to form the blue figure. All parts of the shape are the same distance away from the line. So here's the line of reflection. The point closest to the line is the same distance as the blue one. The red is the same distance away as the blue one. So everything is the same distance away from this line, so it is a reflection. What about this one? No, this one is not. If the blue figure was flipped, the point would be on the left. So this point right here, if it was a reflection, would actually be about right here, and then these points would be over here if it was a reflection. It would look something like this, closer. And this is actually just a translation, and it's just moving to the right. So in this example, I explained what the transformation actually is, but we just need to know that it's not a reflection for this one. Here's some more examples. I think I need to move this up for it. So tell if the blue figure is a reflection of the red figure. So here's the first one. What I notice right away is that this point is closer to the line, but on this one, the point is not closer to the line. So no, this is a translation. If it was a reflection, the blue figure's point would be facing down. So this point right here would be facing down if it was a reflection. Here's another one. Think about it for a second. And no, this one is also a translation. If it was a reflection, the blue figure's left coordinate would be facing the line. So this point would be facing this point. It would be like if they were looking at each other. This is just a translation again. It's being slid to the left. And here's the last one. Let you think about it for a second. And this one is a reflection. The red figure can be flipped over the line to form the blue figure. So if we were to take this red figure and flip it over the line, it would form the blue figure. All right, how to do a reflection on a coordinate plane. So how to reflect on the coordinate plane, we need to move each point on the original figure the same distance to the opposite side of the line of reflection. So the new figure is called an image, and it's showed using prime numbers in the hyperscript. So we have this triangle here, and if we are reflecting it over the x-axis, we want to then have each coordinate the same distance. Instead of being above it, it's now going to be below it, but it's going to be the same distance away. So pause the video here and write that in your notes, and then we'll finish the example. All right, so in this example, we're going to reflect the red triangle over the x-axis, and then we need to write down what the coordinates are of the new image. So here's my line of reflection. It's a little bit off on the axis, but that will change later. But this is the x-axis that it's going to be reflecting over. We need to notice that point A is 1 unit above the x-axis. If you could see, here's the x-axis at 0, and A is 1 above it. And points B and C are 3 units above the x-axis. So 1, 2, 3, 1, 2, 3. So these are 3 units above. These are, or A is 1 unit above. So now I need to reflect it over, so it's going to flip over that line, and it will look like this. And now what we can notice is, since point A was 1 unit above the x-axis, when we reflect it, A prime is now 1 unit below the x-axis. And then points B and C were 3 units above, and B prime and C prime are 3 units below. So each of these now are 3 points, or these were above, now it's below. And then my new coordinates are here in blue. A prime is now at -1, -1. B prime is at -1 and -3. C prime is all the way at 6 and -3. So this is how you reflect it if we're using a coordinate plane. And now we're going to show how to reflect if we just have coordinates. So if we don't always have a coordinate plane, there's an easy way to reflect the coordinates without drawing the picture. So reflecting over the x-axis, if we're trying to reflect it over an x-axis, the y-coordinate will change to the opposite number. So if we go back and look here, we were reflecting it over the x-axis. And if you look, we had -1 for the x, and it stayed the same. And then we had 1 for the x, but then it changed to -1, because 1 on the y means it's 1 above, and -1 on the y means it's 1 below. For b, we had -1. It stayed the same for the x. And then the y went from 3 to -3, because 3 is above, and -3 is below. And the same we did for c and c prime. So whenever we're reflecting over the x, the y changes. So if it was positive y, it's going to change to negative y. If it was negative y, it's going to change to positive y. And then the same type of thing happens when we're doing the y-axis. To reflect over the y-axis, the x-coordinate then is going to change to the opposite. So for that one, if it's a positive x, it's going to change to a negative x. If it was a negative x to start, it's going to change to a positive x. And that's when we're doing the y. So I always try to remember that it's the opposite coordinate of the axis. So if it's the x-axis, we're changing the y. If it's the y-axis, we're changing the x. So now let's do an example. So the vertices of a quadrilateral are P, Q, R, and S, and it gives us the coordinates. We need to draw the figure and its reflection on the y-axis. So we're reflecting over the y-axis, which means I want to use this one here, which means my x numbers are going to be changing. I don't know why that squared you up. So here's our original. P is -2, 5. Q is -1, -1. R is -4, 2. And S is -4, -4. Here's kind of the work. So since if it was positive, we're going to change it to a negative. So now we have -2, -2, 5. -1, -1. -4, 2. And remember that if we have two negatives, it turns to positives, which brings it to the opposites. So now my new coordinates, instead of it being -2, 5, now is just +2, 5. Instead of it being -1, -1, Q prime is now +1, -1. So if you look, the only things that are changing is the x. So these ones here are the ones that are changing from negatives, and now they are positives. And then I could redraw this shape on a coordinate plane. So here was my original, because it just has the letters, and then my new shape has the prime letters on it. So it's reflecting, oops. So it is reflecting across the y-axis right there. So please pause the video here, and I want you to write this down into your notes. And then here's the last example. And this is just describing a reflection. So remember, whenever we're describing a transformation, there's two things we need to do. We need to state what transformation is being done, and then how is it being done. So in our last one, we had translation, and we had to say that it was a translation, and then say which way the translation was going. Was it going left, right, and how many, up, down, and how many units it was. So for this one, we are describing a reflection. So when describing a reflection, we need to identify which is the original and which is the image. The image is usually shown by using prime letters. So in the example to the left, our original image is the blue one. Our original figure is the blue one, and our image is the pink one. And you could see that because the pink one has the prime numbers next to it. And then, when describing a reflection, we need to state the transformation that is being performed. So in this case, it's going to be a reflection. And then what is the line it is reflecting over? So in 8th grade, it's going to be either the x or the y axis. So for this one, here's the x-axis. If it was reflecting over the x-axis, they would be moving that way. So for this one, the line of reflection is going there. I think I already had that down, actually. So here's our line of reflection. And the way that we would then describe this is that the blue triangle is being reflected across the x-axis to form the pink triangle. So please pause the video here and write down how to describe a reflection in your notes. And that is all for your lesson today. So you will have an assignment to do on this. I've done all the different types of examples that are going to be in your assignment to help you. And if you have any questions, you can email me or send me a message. And I'll get back to you guys as soon as I can. So have a great day, and I'll see you guys soon.